Okay, everybody can hear me and see my screen?
Yes.
Yes.
Perfect, thank you. All right, so homework for today was to make our display method for rooms. This guy right here. Elevate, there we go. This guy right here to show the obvious exits leading out of a room. Where if we were to go through those exits right now, when we ask an exit to display itself, it shows us both directions. And let's just kind of show that here real quick. If I go under room CPP and I go to display here and I show obvious exits. Now let me just make sure I'm dealing with the right version of our code here. Yeah, we wrote add exit. Make sure I wrote that. Yep. Okay. So our room itself has an array of exits, and it has a number of exits currently in the array. So remember last time we wrote, when we create our array of exits, when we create a room initially, a room is born with 0 exits and then has an array of things in an array of exits that can be hold as many as max exits number of things. But initially it's 0. Then we gave it the ability to add exits to it. So every single time we add an exit to the room, the number of exits will go up, and we just added one more exit. And if we look back at main here, we created our entrance, our couple of different hallway things. Then we created our exits leading between all those guys. So initially between the entrance and the hallway, this guy right here, between the entrance and this hallway, we have this exit, the exit leading north to the hall 1 and south to entrance. So south to the entrance, north to hall 1. All right, but now what we need to do, and then we also built the exits for between hall 1 and hall 0, east and west, and hall 1 and hall 2, east and west. So hall 1, hall 0, east and west, hall 1, hall 2, east and west. But we'll just focus on these for right now, but we'll get the other exits from these as part of our algorithm. All right, so we're going to go ahead and we're going to add the exit to entrance, and we're also going to add the exit to hall 1. So we'll go ahead and say entrance add exit, and the exit we're adding is called exit 0. And then we'll also say hall 1 add exit 0. So we let entrance and hall 1 know, both of these guys know about this exit. And remember that in room, when we add an exit, we pass it a pointer to the exit. We add that exit to our array of exits, and then we increase the number of exits that this particular room has. And right now, exit has a display method. All right, so if we ask an exit to display itself, it says information about both rooms that it connects. So we'll kind of show this here as a starting point, and then we'll work through fixing it. Go ahead, Hunter.
Why do we have to have those add exits if we already have it in the exit constructor?
the exits itself, so the exit constructor, it knows about the two rooms it connects. So when we build this guy, we build the constructor for that exit. He knows about hall 1 and hall and entrance, but entrance doesn't know about him. Hall 1 doesn't know about him, unless I think maybe what you're asking is maybe we did it. I don't remember. Let me look at exit. Did we tell exits to learn about those guys? We did. Thank you. So he's saying, why did I have to do it separately when I actually went ahead and I had the constructor for exit let both rooms know about the exits they're involved in. So we did actually, these two lines are actually already handled. Well, those two lines handle the same problem as what I tried to do right here. So when I built exit 0 in terms of entrance and hall 1, this constructor went ahead and let these two rooms know about those guys. So I actually do not need those two things. It actually wouldn't have broken things other than the exit would have been in there twice for each of those rooms, which would be a little bit weird, but thank you for that. Okay, so our exits know about the rooms, our rooms know about the exits. So these guys from this picture, this guy knows about both of these. Entrance knows about this guy. Hall 1 knows about this guy. So everybody has all the information they need to make this work. So now what I'll go ahead and do is inside of our room function for display, I'm going to go ahead and I'm going to write a loop that goes through all of our exits. So for int I is equal to 0, can I make this a little bit bigger? I is less than this number of exits, I plus plus. So this for loop is going to go through all of the exits that are currently added to this room. All right, so then I'm going to say this, the exits at bucket I, so this guy right here, this is an instance of an exit. And I want that exit to display itself as of right now. Okay, so if I do this, now when I display a room, so we come back to main, when I tell entrance to display itself, it's going to display that exit. It's going to ask each of its exits, which in this case is one exit, to display itself. Make sure that's from display. Go ahead, Hunter. Hunter, you had your hand up? If you're trying to talk.
No, I don't know why it's.
Oh, okay. No worries. Okay, so let's see why this display method is doing that. Look at display for exit. Oh, it's telling each room to display itself. So the reason why it's this isn't a problem. I was just trying to show you what the issue was. So here, let me put those back in there. So right now it's sitting there and it's like this infinite loop type thing, and I'll show you why here in a second. This isn't what we're ultimately going to do. All right. So, and the reason why it's that infinite loop is, what do we do from within room? Room goes through, and for each one of its exits, it tells the exit to display itself. What does an exit do? Exit tells each of its rooms to go ahead and display itself, which tells this exit to display itself, which tells that room to display itself, which tells this exit to display itself, yada, 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 yada. All right. So we probably don't want that guy in there for our purposes right now. Let's see, does our room have a name? It does. Do we have the ability to get the name? We don't. So just to show this example real quick, I'm gonna teach a room how to give us access to that private member name. A string get name. And then inside of room CPP, we'll go ahead and implement that. And this guy will just return the name of a room. All right, so we taught rooms how to expose for read-only purposes its private name variable. So this will be entrance or hall 1 in our example here. So now inside of exit, I can say this room A get name this room B get name. So this will be room A's name is to the whatever the direction A is. Room B's name is to the direction of whatever direction B is. So now when an exit displays itself, it won't call room's display method, creating that infinite loop. And exit will show both links. It'll say we have one direction heading to a certain room. We have another direction heading to another room. Now, when I run this, we see from an entrance perspective, we have obvious exits. Notice that we have both pieces of information here. Entrance to the south, which isn't a true statement because we're currently in the room entrance, and hall 1 to the north. That's the guy we want. All right. And then from hall 1's perspective, we have obvious exits, entrance 1 to the south, hall 1 to the north. Oh, and then we have these other ones because we created those other exits. So if I go back to my picture here, hall 1 has 3 exits associated with it because we built those exits. Okay, now what we want is we don't necessarily need all of this extra info here. What we wanted to show for entrance is the obvious exit is to the north. That's what we want to get out of there. Okay, we want to get just the north out of that. All right, so what we want to teach this guy, what we want to teach in room CPP, when we go to display, we want to go through all of our exits and we want to ask each exit, give me the direction that isn't me. So I'll write inside of exit. Maybe we have it return a string. And we say get other direction. Maybe this guy takes a room pointer as a parameter. So get other direction, we'll take in a room, and this guy will return the direction leading away from R. So if I was in entrance and I asked this exit to give me the direction, because an exit is always a link between two rooms, and I let this exit know that I'm talking to you from the perspective of entrance, the room, so in our case, R here is entrance, it should give me north. But if I was in hall 1 and I asked this exit to give me its direction away from me, it would return a south because the northbound leads to this guy, to R. So I need to go and implement this. So I am teaching exits how to return a direction given a room, and the direction it's going to return is the other direction, the direction not leading to that room. So what I'll do initially is I'll say string answer is equal to this direction A. I'll just make a guess. We're going to guess to see if it's direction A. Now I might want to change my answer though before I return it, because at the end I'm going to return that answer. All right, so I'm going to assume my answer is direction A, but the answer is only direction A if R is equal to direction B, or if R is equal to room B. If R is room B, the other direction is the one leading to room A, which is direction A. So this is only correct if R is equal to room B. So I want to change it if R is equal to this room A. So if R is actually room A, then I want to set answer equal to this direction B. All right, so I'll assume my answer is going to be direction A. Then I'll say, well, if R is actually room A, then the thing I want to return is the other direction. So I'll set answer equal to direction B and then return it. All right, so one way or another, this function will return the string that is the direction leading away from this room. It'll return the other direction. Okay. So now I need to be able to call this guy. So it's called get other direction. So back here in room CPP, rather than tell an exit to display itself, I'm instead going to tell an exit to get me another direction. I'll put a little question mark in here right now. And what I actually want to output is that other direction. And I'll put some spaces in here, and then I'll do a C out and L at the end. All right, so for every one of my exits, I want to print out each of those exits get other direction followed by a space, and I want to pass myself in, because if I am in room entrance and I'm going through all my exits, which is just one of them, I want that guy to give me the entrance leading away from me, the exit leading away from me. So that would be to the north. So the question is how does a room pass themselves into this function? You do that with the keyword this. Remember, this is how an object refers to itself from within itself. So in here, this keyword is this particular instance of room. That's what this is. So I'm asking this exit to get me the other direction leading away from myself, this particular room. And that exit, this is that function, will take in the pointer to the room, and he'll figure out what's the direction leading away from him. So inside of room, I will do that for all of my exits. So from entrances perspective, I'll get a north. So it'll print out, it'll do north followed by a space, then it'll kick it down the line. That's what I wrote in here. It's only going to go through this loop one time. So it'll be north followed by this space, then the loop will end, and then I press return. That's what that C out there does. So that's what it'll do for this guy. But if I'm in this guy here, it's going to go through 3 different exits. It's going to get a west, it's going to get an east, it's going to get a south. So it'll be whatever order we happen to go through those guys, and it'll be west space, east space, south, and then kick it down the line. So from a particular instance of room's perspective, if this was entrance calling his guy, this loop's going to go through one time. If this was hall one calling this guy, that was what it was, hall one, right? Yeah. If it was hall one calling this guy, it's going to go through this loop 3 times because he's associated, he has 3 exits. And it'll extract the string associated with the direction leading away from him. So out here in Maine, when I tell each of those rooms to display themselves, we now see from entrance, we have an obvious exit to the north. From hall one, we have obvious exits to the south, the west, and the east. And if I want to clean that up a little bit and have it all in the same line, I won't put the end L here. That'll probably read a little bit better. So entrance has obvious exits to the north. Hall one has obvious exits to the south, west, and east. Okay, so I think that solves the homework assignment. So questions about that? The real thing we were drilling there, just to kind of loop back through, is really making sure we have an understanding of this keyword. The thing that I would have expected you to maybe be uncomfortable with and hopefully drill this home here is this part right here. As I mentioned in class, this keyword is a difficult concept to wrap your mind around, even though it's something that we've all been used to as human beings our entire lives. We refer to ourselves as me or I all the time. And when we say those things, we're talking about ourselves. If we're inside of an instance of room here, he can talk about himself like this. That's how he talks about himself. So right here, I'm asking this exit to get the other direction leading away from me. Go ahead, Lee.
The exit CPP, is there an else as well, or because I had done that?
You can have an else. I'll show you. This is what
Okay.
you're talking about there. So he wants to have. So what I did here, let me just show you the alternative. I'll just write it a second time here.
Okay.
So I'll say if R, you probably wrote this. If R is equal to room A, return that.
Yes, I did.
Else, return A.
So
This
there's more than one way to skin a cat.
Yeah, so this is a good example of the thing. There isn't a correct answer to these things. There's a correct output. Let's even say ish, right? But in this case, so in your case here, you asked 2 questions. You said, if this is true, just go ahead and return this answer. Otherwise, go ahead and return this answer. This is perfectly fine. Heck, it's probably even better because I didn't use up memory for this guy. So that's what this implementation does. One way or another, this if structure is going to return an answer. So we have fulfilled our promise that we're going to return a string. What I did up in mine is I just took a blind guess at what the answer was going to be. I just said, nah, it's going to be direction A. And then I tried to prove myself wrong. That's what this if statement says, that if my guess was incorrect, go ahead and change my answer. So whether I got into this if statement or not, when I return answer, it's going to be the correct value for answer. Does that make sense?
Yep, it does.
So, yeah, you can pick your poison if you like this version better. It's going to do the exact same thing. Ultimately, we're doing the same logic. In fact, I'll leave your answer in there because it's probably why create an extra variable if you don't need it. All right, other questions about this? But like I said, if there was one thing in here that was very likely the hang up spot for a lot of people, it's that right there. Because we're so used to saying, well, this arrow something, this was already a confusing concept for us, right? But we had kind of sort of gotten used to saying, okay, this arrow, this arrow, this, all that stuff. But now, what if I only just need this guy to know about me? Is it okay to just pass this? The value of this is a pointer to that particular object. And if you remember back when we first looked at objects, if I go to my constructor for room up here, and I do a cout this in there. So inside my constructor for room, I'm just going to print out to the screen whatever value this holds, which will be some memory address. And then what I do back in main is every single time I create a room, I'll go ahead and do a cout on that room. So this will print out the memory address entrance holds, which will be the identical memory address to this inside of the instance of room that was entrance. Similarly, if I print out cout all 0, cout all 1, cout all 2. So if every single time when I create a room and that constructor for room internally will be printing out the pointer, the value of this, I will then immediately on the next line go ahead and print out my pointer associated with that room. So we should see the same memory address back to back 3 different times, but they'll be different memory addresses. It teach that guy how to do couts. Main doesn't know about couts right now, so let me just put that in there. Stream space. Now he knows about it. Notice that this is this keyword inside of the constructor for entrance. This is the value of entrance inside of main. Those are the same memory addresses. This is this keyword. This is the value of entrance. In this case, I am inside the constructor when I'm in the middle of building the room that is entrance. In this case, I am outside of the room class inside of main, printing out the value of my variable entrance. We see that this and the variable entrance hold the same value because I don't have access to the variable called entrance inside of room. Similarly, hall 0, this is this keyword. This is the hall 0 variable. Hall 1, this is this keyword. This is the hall 1 variable in main. Hall 2, this is this keyword. This is the hall 2 variable in main. So hopefully this finishes connecting those dots with this keyword that we have there, because if we're inside of room, shrink this down, I can't say entrance or hall 0 or hall 1 or hall 2 in here. I don't have access to those variables. So I want to print out whoever I am. That's what this keyword is. It's a pointer to myself. And based on that knowledge, when I am talking to an exit and I want to let that exit know about myself, I can just pass him a pointer to myself. And that is stored inside of the keyword called this. All right, so questions about any of that? Here, I'll comment out that there in case you want to play around with it. So this whole homework assignment was about this keyword, really drilling that home. Because the amount of new code that we really wrote, the stuff I did at the beginning was to show you the problem, but the amount of new code that we wrote was this guy. And that. So not a whole lot of code that we actually added to our program, but it was an important chunk of code. All right. So go ahead and save. So what would come next? So now I have kind of the start of my little map here. I only have a couple of rooms. I have entrance, hall 0, hall 1, hall 2. Okay. And I don't have this exit represented. I don't have this exit represented. So this is my whole little world and my dungeon right now. So now that we have the dungeon created and we've proven that our rooms, well, at least visually, that our rooms seem to know about their exits, I want to go ahead and put something into this room. Well, what might exist in this room? Well, maybe it's a player. So I might have a player. So if we just kind of draw a picture here. Maybe this is my player. And we'll make him. Maybe when the game first starts, our player's in this room. And then we ask the player, what do you want to do? Well, he only has one option. He can go to the north. So if he types in north, it'll remove him from this room and put him into this room. And then it'll show him the current room he's in and what the available exits are. Well, he can go back to the south if he wants. He can go to the west if he wants. He can go to the east if he wants. All right, so we're going to allow our player to kind of wander around this. But that's going to require me to first create a player object and then continually ask this player object, what do you want to do? Assuming he's just in travel mode right now. He's not, trying to kill rats or anything. He's just moving around. So we'll create him. We'll initially put him into the entrance because that's where he's going to belong right off the bat. So what does this mean? It means that rooms not only hold exits, now they potentially can hold a player. We'll make a single player version of our game right now. In the next course, we'll look at how do we expand on that a little bit. But, so we don't need to hold a collection of players. We just need to hold a player, the current player. And maybe we say a player only has a name. So if we come and we design what our player object looks like, it's going to have a string name. All right, so we'll keep players pretty simple for our example here. So let's go back to our code. And let's go ahead and add our player class. We'll have our player HPP. Go ahead and have class player. And a player is going to have a private string name. They'll have a public constructor for player that takes in the name. And then we're going to go ahead and we'll give it the ability to expose its name to other people just as read only. So we'll go ahead and have a string get name. Now, in order for us to use string in here, we will need to include the string class and namespace standard. Now we're allowed to use strings in here. So this will be our header file for this guy. And now we're going to need to go and write the CPP file and then implement these guys. So we're going to create player.cpp. And this guy is going to include player HPP. All right, so the constructor for our player will be this name is equal to name. And get name will just return this name. So player is pretty simple here. Not a whole lot going on. I'll go ahead and just run this real quick and make sure we don't have any major syntax errors with our still compiling. Oh, it's connecting to the server. Hopefully everybody can still hear me. My internet's not out.
Yeah, you're still
Yeah,
good.
you're good.
Okay.
I don't know if you're on FalconNet, but it's super slow for me today.
No, I'm actually at home right now. That's why we're on Wi-Fi. Okay, let's give it another college try here. If it times out here, it's not a problem. I'll just keep trucking. Maybe by the time we add some more, I'm pretty confident that what we've written so far is fine. Not a whole lot going on here with player. String, namespace, class player, string name. Here's our constructor. Here's our get name. We went and implemented these guys over here. So constructor takes in a name as a string. I set the field associated with this player equal to whatever was passed in. And then our getter here, get name, just returns this name. So I think we're okay. This is probably something with online GDB or something. So let's just keep trucking.
It says refresh it from the upper. Yeah.
Oh, this guy?
Yeah.
Okay. Oh, I forgot my semicolon here. Okay, so he's happy enough. So now we have a player. This idea of a player exists, and I can come in here and at the very top I can say we have our. Well, I need to let this guy know. Include player HPP. So I'll let main know about that guy, and I'll create a player pointer. Call this guy the player, and he's going to be a new player named put me in there named Mike. So we now have a player. We have all these entrances. We have all these rooms and exits. So what we've created right now is this scenario where we have really our whole world looks like that right now. So we haven't created all the other things, but we have a player that stands on his own. Then we have rooms and exits, and those guys are linked together. So the very first thing I want to do here is I want to get this player into this room. So how do we do that? Well, we need to let rooms know about players. So a room needs to be able to have a player inside of it. So let's go back to our room here. And we're going to add another field to a room. So a room is going to need to know about player. Now, a player is probably also going to need to know about rooms. So we're going to go ahead and proactively do our fix here, where what I'll actually do is I'll just say class player up here. And then inside of room CPP, I will include player HPP. So this finishes telling us all the stuff players can do, but this makes sure that I can have a player inside of here, which then allows me to say, I'm going to have a player pointer called the player, or whatever I want to call it. Okay, so now we've taught rooms how to hold on to a player. We haven't taught them how to get a player yet. We just gave them the ability to remember if they have a player in there or not. All right, so now in room CPP, when we first create a room, regardless of how we're creating the room, remember last time we looked at our generic constructor versus a constructor that takes something. We're always using the constructor that takes something right now. In fact, we would probably say this guy never makes sense, but it was just for an example that you can have more than one constructor. But we're going to go ahead and we're going to say this, the player is equal to null. When a room first comes into existence, it does not have a player in it. When it first comes into existence, it does not have a player in it. So we'll just go ahead and when we're first instantiating a room, we're first constructing a room, we'll set the player equal to null. But now we do need to have the ability to add a player to a room. So I'll go down and let's go ahead and create a public function, void add player. We'll have it take in a, actually, I'm not going to call it the player there because I'm not necessarily specifying this will be the player. I'm just specifying it will be any player. Well, since I'm only going to store one player in here ever, and for our time period, this is fine. I'll call it the player. That way we keep driving point that home or home that point, this dot the player equals the player. So I want to have the ability to add a player, but I also want to have the ability to remove a player, handing me the player that was removed. So I'm going to teach a room two new tricks. One is how does somebody else hand us a player and me remember that player that was just added to us? And secondarily, how can I remove the current player from my room and hand it to somebody else who might want that player for whatever reason? Okay, we don't have to solve the other side of the problem here. We're just teaching a room how to send and receive players. So we'll go and implement those couple of things. This guy's in the room class, so we can make sure we're going to link it. So when we add a player, we're going to go ahead and set the player equal to the player that was passed in. When we remove a player, we're expected to return the player, but we also, when a player leaves a room, when we remove a player from a room, we want to make sure that we have left that room's the player variable as null, so that the player has actually left the room. So I might say player pointer, I'll call this guy player to return, is equal to this, the player. So I'll remember my pointer to the player inside of this variable right here. And I'll also remember to, in the end, to return my player to return. But before I return that, I want to set this, the player, equal to null. All right, so I'll go ahead and remember the player I'm going to return. Then I'll actually empty out the player associated with this room. So this player has left the room. And then I'll return the player that we just removed to whoever called this function. So this removes a player from a room, handing whoever called it the player that we took out. Okay. So again, go back to our picture here. This is what everything looks like right now, but now I've taught rooms how to add a player to them. So now, in order to make this a reality, I go to main and I tell entrance to add a player. Which player? The player. Entrance, add player, the player. And here I'll go ahead and actually create my player lower down, just so it's right by where we add it. I didn't use it before then anyways. So I've built my rooms and my exits up here. Now I go ahead and I create my player. So he exists separate from a room. And then I'll go ahead and add that player to the room. And what that effectively did is it told this room to store this player as his player. All right, so now I would like a player to then be able to look around in the room he's currently in. So I'll go ahead and go into player. And we're going to write a function. It'll be void. We'll just call this guy look. Actually, before I do that, let's add to room the ability to show not just the exits, but also who else is here. So inside room here, we've messed around with display, where we're showing the name of the room, we're showing our obvious exits. Now we want to do something like a see out. Also here, like that. And we want to show the player that's currently there, currently in the room. Now, all rooms have the ability to hold a player, but not all rooms actually have a player in them. So when a room is first born, it does not have a player. So we only want to display the player's name if the room has a player in it. And let me show you what I mean by that. So if I come down here, and the display method for a room automatically says something like see out this the player, get name. We taught players how to give us their name. And in our example, our player's name is Mike. All right, so if we just make the assumption that a room has a player in it, and I go out to main here and I choose not to add the player to the room, but I still say entrance, display yourself. So in this particular case, entrance does not actually have a player. I have a player that's sitting outside the dungeon. My picture right now would look like this. Entrance looks like this. I go ahead and tell entrance to display itself. Entrance comes in here and he prints out his name. He goes through and shows all of his exits. And then he has this also here thing where he shows, he makes the assumption he already has a player in there and he tries to get the name of that player. So I go ahead and run this. Second, I think we had this thing before where it doesn't give us the error message. Let me just make sure it's getting to that code. Yeah, there's the also here. Yes, it's really a shame it doesn't give us an error message. It really should. So notice here that if I don't ask the player for its name, it will show me the also here and then end the line. So both of those things show up. But if I do try to get the name of the player, which in this case, we don't actually have a player, it just doesn't even show me. It kind of crashes out, doesn't even show me the also here. Go ahead, Lee.
Is it because of the null? Because it's null?
Correct. Yeah. I mean, the behavior is just what I'm saying is I would expect right now to be getting some sort of a traditional C++ compiler might show a segmentation fault, you know, because I'm accessing memory that doesn't exist because of the null value, right? I make this to be a truth. Right now, entrance exists, the player exists, but these guys are not associated with each other yet, right? I never actually added my player to this room. But now I'm asking this room to display itself, and he's making the assumption that he has a player in there that has a name. Well, if I ask nothingness, if I ask the null value to give me its name, the computer's not going to be so happy about that because I'm talking to an empty memory address. There's nothing there. And this is showing me as if there's nothing there, but there's really no reason why I shouldn't get the also here printed out here. Because really my problem is right here on this line. I just want to check something real quick. If I say end L here, does it show up? It does. Interesting. All right. It has to do with how C out is working. Since I did not kick it down a line here, I just kind of said also here and left it at a space. It's waiting to resolve the rest of that line before I can put it in there. So it kind of puts this in a buffer ready to display to the screen, but not actually displayed to the screen yet. And then it tries to do this and dies. You know, this is a word error. Something should show up and saying, you know, says, you know what, you are asking for the name of something that does not exist. This dot the player is not a thing. Its value is null. So you're asking nothingness for its name, and that's not going to fly. And that's why we're not getting anything here. All right. So that means that what I need to do is I need to situationally get the name of this player. I need to only try to get the name of the player if this, the player, is not equal to null. If this room has a player in it, then I want to get the name of that player. So now I get my also here. It doesn't try to get this because this room currently has a player that's equal to null, and then it just kicks it down a line. If I go back to main and I go ahead and let my entrance know about that player now, I add the player to that entrance, and then I run. Now I get Mike is also here. Okay. So now we've taught rooms how to display themselves. a little bit more. Not only does it show its name, not only does it show its exits, now it also shows if there's a player, who that player is. All right, that makes some sense. Now, this is from a room's perspective. A room knows about its player. But now we probably want, so if any one of you, if you're standing in a room right now or sitting in a room, you know about the room you're in. Presumably, if based on our example here, if we give your room a consciousness, your room knows about you too, which is kind of creepy, but that's just the way it's being written, right? So rooms know about the player, but the player certainly knows about whatever room they're currently in. So that means that not only do we need to let rooms know about the player that's in them, it would probably be beneficial for a player to know about their current room. So a player might have a room pointer called current room, and we'll need to give him access to the room class here. And then what we'll go ahead and do is inside of room CPP, just grab this variable here. We'll go ahead and include player HPP. We're going to let rooms know about the rest of the abilities of a player, even though we just in the header file let him know about the existence of a player. This prevents us from getting into that infinite loop of including a file that includes the other file. And I'm going to go ahead and I'm just going to dump this no argument constructor. I think we've talked about that enough, and it's just making this code look weird.
It's got 2 copies of the player .hbp up there.
Oh, thank you. Oh, it already had that because we had previously taught rooms about that. Rooms already knew about the player. It's the player that we're writing here that needs to know about the room. So inside of player HPP, we're teaching him about current room. And he needs to know about the room class. Player then is going to need to know about the room class. And when we construct a player, initially, we're going to set the player's current room equal to nothing. When a player first comes into existence, go back to our picture here. When we first build that player, he exists outside of any individual room. We then have to place him into that room. Okay, but he exists outside of any individual room initially. So now a player, when it's first built, knows about gets its room set to nothingness. So now we need to teach players how to become aware of a room. A player, when he's added to a room, should probably become aware of the room he was just added to. So let's go ahead and create a function called set room. And set room inside of player will take a room pointer as a parameter, and it will set this particular player's current room to that room. So we're teaching a player how to allow somebody else to let them know that they're now in a different room or in a room for the first time around. Go ahead and implement this. This dot current room is equal to R. So if we call upon an instance of player set room and we pass it a room, that player will set his current room equal to that room. So now a player can know about the room. Well, who might let the player know about the room? Inside of room, when we add a player, we let that room know about the player, but we can then also say the player dot set room. So we're calling this guy right here. From a player's perspective, we're calling his set room, and this takes a room pointer as a parameter. So from a room's perspective, go back to our picture. When we're asking entrance to add a player, and entrance needs to then let player know about himself. What do I replace that question mark with? This is inside of room CPP. So when I'm adding a player to a room, I'm setting the room's player equal to the player. And then I'm going to go ahead and let the player know about this room by calling his set room, which takes a room pointer as a parameter. What do I pass in with this question mark?
This.
Pass in this. Yep. All right. So add player takes in the player we're adding. The room becomes aware of that player. And then we go ahead and let the player know about this room. Hold on a second. Give me 1 second here, sorry. Okay. So we'll let the player know about the room by passing the pointer to this particular room, which is just the this keyword. So now a player knows about the current room they're in. And we'll prove this here in a second. Oh, where's my main? Okay. So we let entrance know about the player. So we added the player to our entrance. That comes into add player here. The room entrance becomes aware of the player and then lets the player know about itself. So our player, the player, should know about the entrance. Let's go ahead and prove that. So we're going to write a function inside of player. Let's call this guy look. The idea is we're going to teach a player how to look around. All right. And when a player looks around, player class. When a player looks around, what he should do is he should see if only if he's in a room. So that means if this current room is not equal to null. So if he's in a place, if he's actually in a room and he tries to look around, what should he do? He should see whatever that room is. So we'll ask that room to go ahead and display itself. All right, so when we tell a player to look, if he's currently in a room, he will ask the room he's currently in to go ahead and display itself. And we know that rooms know how to do that because we've written that a bunch today. So rather than telling entrance to display itself, we'll go ahead and we'll tell the player to go ahead and look around. So after we've added the player to the room, we'll tell the player to go ahead and look around, and we will see set room. Oh, I have a dot there. This is an arrow. So this is from the player's perspective. When he looks around, he sees that he's in a room called entrance with obvious exits north. Now it also shows that he's standing here. I don't think that's a major problem in our implementation right here because we're not dealing with a multiplayer thing where also here would be you and potentially 3, 4, 5 other players. Because those 3, 4, 5 other players, you wouldn't want to see yourself along with 5 other people. You would want to just see the 5 other people, pretty similar to what we dealt with for homework for today, where a room only showed the exits other than the ones leading to itself. Okay. So now a player can look at the room that he's currently in. What we want to do is we want to teach a player how to move. How to move in a direction. This function, let me actually write it this way. This function should take a direction, maybe something like north, as a parameter. Have the player look through its exits, find the room leading in that direction, and ultimately remove the player from the current room and place them in the appropriate destination room. The player should look around after they arrive at their new destination. All right, so what we want to be able to do is inside main, the player will look at his current room, and then we want to say, the player move north. This should have the player take the exit to the north. When a player moves to the north, no longer are they in entrance. Now they're in hall 1. So when the player looks around, they're going to see they're in a room named hall 1 with exits to the west, the south, and the east. So your homework implement the move function inside of player. The player. So implement the move player inside of the move function inside of player. And let me get the current code. This is the current code. Such that a player can leave one room and enter another. That's the link to the code and the self. All right, so we'll go over that on it's not that much code, but hopefully it's really drives this point home that what we're doing. So we'll finish that on Thursday, and then we'll go over details on the final exam. Questions, comments, concerns, bribes?
Are you gonna be back Thursday?
I plan on it, yeah.
Okay.
In fact, tonight we have the senior seminar presentations on campus. I've posted several times, so I'll be on campus tonight at 5 to 8 p.m. in the collaboratorium. So I encourage all of you to come and watch the senior presentations, or check out or maybe even do your homework in that area, just so you're kind of filling out the audience so they're not speaking to an empty room.
Will they be recorded?
Well, that's kind of up in the air, because I think each student is going to kind of be using their own laptop. And I want to encourage people to come in person so they're not speaking to an empty room. So that's kind of why we're not purposely doing it as like an online Zoom thing. Because then what will happen is everybody will just attend via Zoom. And so the short answer is some of them probably will be recorded, but not all of them. All right, I will see everybody on Thursday.
Professor Littman,
Yep, what's up?
I have a question on the final, just when it was gonna be.